Hi everyone, am I audible? Okay. Just let me know if everything is fine. Audio, video, everything. Okay, great. So let's get started, right? So today we are going to discuss AIMT 5 solutions, and this will be a quick discussion in the sense that since the exam is very near, so I will not go into way beyond that question. So we will refrain ourselves to the question itself, right? Okay. Let me know if by the way everything is fine. So let's get started. Now let's see the very first question, which was really a nice question, which was from computer networks background. And now this question is saying, suppose this H1 wants to send a packet to S3, right? Wants to send a package to S3. In that case, what are these T1, T2, T3, T4 contain? I mean, as a destination MAC address. That's what it is asking, right? So let me know if you have seen if you have attempted this question correctly. How many of you have attempted this question correctly? Okay, some of you have attempted right. Some of you have attempted correctly, and some of you have not attempted right. Okay, great. So let's just get started. Now, see, if H1 wants to send some packet to S3, then tell me what are the steps. So H1 will first check whether this S3 is in the same network or not. If S3 is in the same network, then it will send directly. Otherwise, it will send to the default gateway, right? So R1 is the first router that comes in the between. So H1 will send to R1. Now in between H1 is coming, that's okay. See, H1 wants to send to whom? R1. So the destination MAC address should be R1. So the packet leaving H1 should be having the destination MAC address of R1, not S1. So that's wrong. This option is wrong. This option is wrong because it is written S1 here, but it should be R1, right? It should be R1. That's why this option is wrong. I hope you understood that H1 wants to send to R1. If S1 is coming in between, that's okay, right? I mean, it is not sending to S1. That should be clear to everyone. It is not sending to S1. It is sending to R1. So hence, this is wrong. This is wrong, right? What about this? Yeah, S1, if that is leaving, it should be R1. This is correct. What about this? If R1, if it is leaving, then it should be R2. Yes, this is correct because the R1 will send to R2, right? R1 will send to R2. R1 will say that, okay, I want to send to S3, but S3 is obviously not in the same network. So R1 will send to R2, and R2 will send to S3, not S2. Okay, so see, R2 will send to S3. If S2 is coming in the between, that's okay. If S2 is coming in the between, that's okay. So that's why this is also false option. So B and C are the correct answer, right? B and C are the correct answers. This question is taken from this standard university. Let me know if you have understood this correctly. Okay. Now let's see this question. This question is also easy question. What they are saying, that consider a sender view sequence numbers in the go back N protocol, right? Now they are saying that first sequence number is k, first sequence number in the window is k, and the last sequence number is k plus 3. So k and k plus 3 is the first and last, which means k plus 1 and k plus 2 are there in the window, right? Now what else they are saying? They are saying that which is true, right? Which must be true. Okay, and I, like sequence number I associated with the packet number pi. So pk sent and acknowledged. So you don't know. See, that is in the current window. Maybe you want to send it, right? Maybe it is not yet sent, right? You just want to send it, right? Maybe the window has been shifted, and then maybe probably you just want to send it, right? It is sent and acknowledged. Acknowledged, you are not very much sure whether it is acknowledged or not, right? pk plus 3, pk plus 3, it is not sent. Okay, you don't know, right? You don't know whether it is sent or not. It is in the window, that's okay, but you don't know whether it is sent or not. So they are saying must be true. Now if pk plus 2 is sent, which means if this is sent, then pk plus 1 must have been sent. So they are saying, obviously, if this is sent, then this must have been sent. So that's why this is true, because this is go back N protocol. So that's why this is true. If pk plus 2 is not sent, then pk plus 1 must have not sent. No, that's not true. If this is not sent, maybe you have sent it, right? Maybe you have sent it. So let me know if that is understood, right? Okay. Okay. So some people are asking here, some doubts here, that what if this is hub? No, it doesn't matter. It is hub, it is switch, it doesn't really matter. You just tell me H1 will send to the default gateway, right? Isn't it? See, H1 wants to send to S3, so H1 will have ARP request. that okay, ARP request for the default gateway, ARP request for default gateway MAC, right? Default gateway MAC. And how H1 is going to get the IP address of R1? How H1 will get IP address of R1? Can anyone tell me how H1 will get IP address of R1? Can anyone tell me? Yes, using DSCP. Using DSCP, it will get the IP address of the default gateway, its own IP address of the local server. So basically, using DSCP, it gets multiple things. What are the things that H1 will be getting using DSCP? Tell me. So using DSCP will provide to H1, right? To H1, DSCP server will provide to H1. What are these things? It will get IP address of own, right? IP address of H1. It will get local DNS IP address. It will get default gateway IP address, right? Default gateway IP address. Let me know if that is clear to everyone, right? Okay. So I hope that is clear. So now if the switch or hub that is coming in between, that's okay. I mean, it is not sending to it, right? H1 is not sending to switch. So the destination MAC address has to be R1. It is in the between only, okay? So this is a standard university question which I have taken from this UCSD university. This is a standard university question. This is not even the question made by me. Okay? Cool. Now again, this question was easy, which I have taken from CMU University. The answer is C. So basically, we are saying here that size of double is 8, right? So which means they are saying this is an array. 1, 2, 3 is there. 1, 2, 3 is there. 4, 5, 6 is there. Now in this array, 1, 2, 3 is there and 4, 5, 6 is there. Now what you want to do? You want to say that A of 0 address is this, right? Now they are asking A of 1 address. So they are just asking, I mean, like what should be the address of this particular element, right? So what you will do? These are the how many you can say doubles in between? 3 doubles, which means you need to add 24. If you need to add 24, then this address plus 24, this address plus 24, but in the hexadecimal. So 24 in the decimal is equal to 18 in hexadecimal, right? So that's why you ultimately need to add 18. How many of you made it wrong? How many of you just added 24? Let me know. How many of you added 24 and made it AH correct? See, answer is D, right? Answer is D. How many of you made mistake by making AH correct? Let me know. Okay. So answer is D, right? Sorry. Yeah, I think answer is D, or I think by mistake this is C, but this is a typing mistake. So answer is D. Okay. I hope you understood. This is easy question only. Let me know if there is any doubt in this question. Let me know. If there is any doubt, you can just let me know now. See, you just need to add 24, but that too in the hexadecimal, right? That in the hexadecimal. And that's how you need to solve this question. Okay, great. Now let's just move to the next question, right? Let's just move to the next question. So this question is also easy and nice question. What this question is saying that at the least value of k such that fk is n. So basically they are saying fk is greater than n. So basically they are saying that if you run this loop, right? So what is the fk? Fk is basically this loop is running k times, right? This loop is running k times. So fk is a value returned by this particular function. So fk basically the value returned is x, and fk is basically, you will say that for example if let's suppose, okay, let's just see that how many times this let's just see that what it is returning first of all, right? Let's just see what it is returning in terms of k. Can you tell me what it is returning in terms of k? This is x square, then it will, x is currently 2, right? So first it is 2 square, and then the whole square, right? So 2 square will be 2 power 4, and then 2 power 8, then 2 power 16, and so on, right? So basically this will be 2 power k, right? So 2 power k. You can say this is 2 power 2, 2 power 3, 2 power 3, This is 2 power 2 power 2. This is 2 power 2 power 4 and so on, right? If you're running it 4 times, then it is something like this. If you're running it k times, then x value will be 2 power 2 power k. X value will be 2 power 2 power k. Now, which means this fk is nothing but 2 power 2 power k, right? If it has to be greater than n, then you can find out the value of k, which will be log n, right? Okay, understood? Okay, so A is the correct answer here, right? A is the correct answer here. This is easy question only. So what they are saying, that what is the value of k such that fk is greater than n? You might got confused that what it is asking. Basically, fk is nothing but 2 power 2 power k. If you have to have 2 power 2 power k is greater than n, then k has to be at least log n, right? Least value, at least log n. Understood? Okay. Now let's just see this question. This question is based on binary search, right? This question was based on binary search. What they're saying is that if we have numbers between 1 to 1000, this is also a standard question. Okay, I mean, if you Google out, this is a question from GRE. Earlier there was GRE in computer science itself, right? GRE in computer science itself. So this is a question from GRE in computer science. Nowadays there is no GRE in computer science, but earlier that was a GRE in computer science. So this is a question from GRE computer science. Okay, understood? Great. Now what they're saying, if you are having 1 to 1000, then what is the value of I mean, how many times this Mary need to ask the question in the worst case if it is using optimal strategy? So you can say, first of all, they will ask, Mary will ask for the middle value, whether the value is greater than 500 or less than 500, so that it can narrow down by 2, right? It can narrow down by 2. So basically, just like binary search, it will be log of 1000, right? Log of 1000. So you can just do it. 1000 is approximately 2 power 10. So it is basically 10 is the answer, right? I mean, 32 cannot be the answer. 500, 999, these cannot be the answer. Understood? This is just a binary search. Okay. Now let's just see this. This question I have taken from Berkeley University, and let's just see that what they are asking. They are saying that this tree is given to you, right? So they are saying which of the following frequency ABCD can generate with the following tree. Which of the following frequency for ABCD can generate the following Hoffman tree? So this Hoffman tree is given, then which can be generated? So you see here that C is definitely the answer, right? C is definitely the answer. Why? If all are equal, then you can definitely get this tree. If all are equal, then you can definitely get this tree. So C is definitely the answer. Let me know if there is any problem in this C. C is definitely the answer. Now let's just see if A can be the answer. A is saying 0.2 and 0.1. I mean, you will first combine C and D. So according to A, you will combine C and D. And this is 0.3. This is 0.3. Now you will combine B to this, right? Now you will combine B to this. So you will not get this A. You will not get this tree. So hence A is not the answer, right? A is not the answer. Now let's just check this B. This B is saying you will combine 0.2 and 0.2, right? So which means you will combine C and D, and then this is 0.4, right? And then you will combine 0.25 and 0.35, because this is 0.4, you won't combine this. So A and B you will combine, which is 0.25 and 0.35, which is 0.45, right? 0.45. Okay, there might be D also. So sorry, 0.55. Okay, the total frequency seems not to be 1, right? No, for each iteration you just need to ask one question. So here for each iteration you just need to ask one question, whether it is lesser, then they will say yes or no, right? Lesser or greater, whatever you want to ask. Okay, sorry, this is 0.6. This is 0.6. I'm sorry about this. This is 0.6. Yeah. So these are summing out to be 1. That's okay. Okay. So B is definitely the answer, because you will combine 0.2 and 0.2. You will combine 0.2 and 0.2, and then you will combine these two, right? You will combine these two. So let me know if there is any difficulty in B, because some of the people are saying that there is a difficulty in B. So what is the difficulty that you are facing in B? B and C are the answer. And similarly, you can see D is not the answer because you need to combine A and C. If you combine A and C, you won't be getting this, right? You won't be getting this. So that's why D is also not the answer. B and C are the answers. Okay. So this question is taken from Berkeley University. Now let's just see this. What they are saying, consider the following array. And now we apply a certain sorting algorithm and observe the array has been modified to this while the sorting is in the progress, not yet completed. So they are saying while the sorting in the progress, they have modified this to this. So this array was given to us, and now in between this has been modified to this. Can it be merge sort? Let's just see, it is a MSQ, right? It is MSQ. Okay. So Ayush is saying that some people are having this misconception that low frequency in the left. No, yeah, okay. So no, that's completely false. It's never true that low frequency is on the left side or right side. You can keep it on any side. Left or right doesn't really matter. Okay, left and right doesn't really matter. I mean, what I mean to say that if you, let's suppose, if you want to combine 0.2 and 0.3, then you can combine like this, or you can combine like this. Doesn't really matter. 0.3 and 0.2. Okay, 0.3 and 0.2. So by the way, who is like, I mean, teaching these misconceptions to you? Okay, let's just check this. If this array is given to you, then they are saying the final resultant array is this. Then which method could have been applied? Is this merge sort, bubble sort, quick sort, insertion sort? Let's just see. See, see. Merge sort is saying, okay, this was MSQ or MCQ, doesn't really matter, but yeah, that's fine. So merge sort is saying that you have one array, you will keep it in two partition, you will sort it, right? And you will to sort it, you will further divide it into two. So let's just see that what we have. So this array is given to you. So let me just go to the next page. Okay, so let me just go to the next page, and let's just see what is there, right? Okay, so this is the original array. And this is the modified array, right? This is the modified array. Now you just notice that what is happening. Can you obtain this using the merge sort? Let's just do step by step. So see here, merge sort will divide into two half. This is 4 elements, 5, 6, 7, 8, 9, 10. Okay, so merge sort will divide into two half like this, right? You cannot mix this with this, right? I mean, unless and until it is ultimately sorted. So basically merge sort will sort this. So check if this is basically sorted, right? This is sorted. So merge sort will divide into two half. So it will be sorted and it will be sorted. So yeah, this is sorted and this is sorted, right? So yeah, this can be definitely using merge sort. Merge sort can definitely get it. Okay. Merge sort can definitely get it. What about the other sorts? Bubble sort. Let's just check if bubble sort can get it. Bubble sort says that you need to basically compare these two, and whichever is greater you will be, or whichever is lesser, maybe you can say. Okay, if you want to sort in the increasing order, so whichever is lesser you will keep it on the left. Okay, so you will compare these two, and whichever is lesser you will keep on the left. Now 32 and 33 will be compared, and 32 will keep on will remain on the left, and then 5 will come. Okay, so basically 32 and then 5 will come. Now let's just see that what is happening. See here, if you observe between these two array, then it is for sure that these half elements are not interacting with the other half elements, right? So I hope this will get reflect in the bubble sort. If you do this, then definitely some of the elements of this will get intermixed with this, right? Some of the element of this will get mixed with this. So let's just see. Let's just quickly check. Okay, in the bubble sort, can you get this kind of the array? Let's just quickly check. See, in the bubble sort, if you apply the bubble sort, then you can say, see here, this 32 and 33 will get compared, then you can say 32 will be here, and then 33 and 5 will get compared, then 5 will be here, and then and 33 will be here, right? Okay, and then 33 and 2 will get compared, and between these two, 2 is smaller, so 2 and 33, and then 33 and 14 will get compared, so 14 is smaller, 14 and 33, and then this minus 4, so minus 4 is smaller than minus 4 and 33. So now I hope you can observe that you are having minus 4 in the left half, right? So since you are having the minus 4 on the left half, that means that bubble sort will intermix, right? Bubble sort will intermix. So here the left half is separate and right half is also separate. Okay, so left half is basically this one and right half is this one. So if you're keeping the minus 4 here, then there is no way that minus 4 can be here in the bubble sort, right? In the bubble sort, minus 4 is coming on the left half. Okay, okay, so in the bubble sort, minus 4 is coming on the left half, and here the minus 4 and what is given here is the basically this, sorry, this is the half. What is given here, the minus 4 in the right half, but in the bubble sort, minus 4 is coming in the left half, so bubble sort is not possible. What else? Quick sort and insertion sort. So let's just check quick sort and insertion sort, right? So in the quick sort, what we do, in the quick sort, there's a pivot element, right? There's a pivot element, and we say that, okay, if this is the pivot element, left of it should be less than equal to, right of it should be greater than equal to, right? So let's just check if anything is pivot. So 5 is not pivot because right of it is not greater, because minus 9 is not greater. Similarly, 33, I mean, anything like this cannot be pivot because in the right you have minus 9, which is not greater than any element. So that's why these cannot be pivot. Minus 9, can this be the pivot? Left of this should be lesser than equal to, no, minus 9, there is nothing lesser than equal to minus, so minus 9 cannot be the pivot, because if the minus 9 is pivot, then it has to be on the leftmost position. Okay, so there is nothing pivot here. Can the minus 4 be the pivot? Left of this should be lesser than equal to, so no, these elements are greater, right? So basically there is no pivot. You cannot have pivot. Okay, so there is no pivot possible. So I think in this Huffman, there is one more time, like I don't remember exactly. I have not paid enough attention that people are having this misconception. Otherwise, I could have exposed that misconception. So there is one more time someone told me that this is some misconception that, okay, the left should be on the I mean, lesser should be on the left. No, in the Corman it is specifically written. I mean, in the Corman, I don't have the screenshot currently, but in the Corman it is specifically written that, I mean, there is no such rule, because I know that someone has pointed out it 6 months before. At that time, I have sent him Corman screenshot. At that time itself, I have sent him Corman screenshot. Okay. So in the previous year AIMT also, there was such question. Okay. In the previous year AIMT also, there was such question. So there is no concept, like you can easily think that, I mean, left and right doesn't really matter. Should be, I mean, lesser should be on the left or right. It doesn't really matter. You just think conceptually. Why will it even matter? Right, because the both are having the same code word length. The length will be same, right? So why will it even matter? Okay, yeah, 39 could be the pivot. That's true. Okay, so let me just go to the quick sort example. Yes, 39 could be the pivot. That's really true. Okay, so yes, that's true that 39 could be the pivot here. So what is the answer that we have given in the answer key? What is the answer? Do you remember? So by the way, this question is from Berkeley University. Okay, this is a question number 20, and this is let me just put the link here. This question is from Berkeley University, which is question number 20. Just a second. Okay, so let's see this question. This is actually from from Washington University. This is a question from Washington University. Um, yes, because 39 I'm keeping on the left, on the right most. Then 39 could be the pivot. That's true, right? 39 could be the pivot. Basically, the implementation doesn't really matter because what I'm doing here on the left of this, what I'm doing, what is the arrangement of this, it doesn't really matter. So basically, as long as satisfy the property that okay on the left of this should be lesser than equal to, then could be the it could be the pivot, right? How I'm assigning it doesn't really matter. So the answer that they have given is merge sort only. Let me just tell you the answer also. So this is the answer that they have given, but maybe they have followed their own implementation or something. Okay. So see, in the answer, this is the question number 2b. In the 2b, they have only given the merge sort. Okay, they've only given the merge sort. In this 2b, they have only given the merge sort. So, but yeah, this could be the quick sort also, right? Because as long as quick sort is concerned, the left of this should be lesser than equal to. And what is the exact implementation? What is the arrangement of this? It doesn't really matter. Okay, so maybe they have followed some particular implementation. Okay, maybe in their class they have followed some particular implementation. Okay, based on that they might have given the answer. Okay, they might have followed some particular implementation. Based on that they might have given the answer. Okay, so they have actually, let me just tell you the whole question. Okay, let me just tell you the whole question. They've actually written what they do mean by quicksort. Okay, minimum number of swaps should be 0 in that DA question. So by the way, the answer here is A and C. Okay, I mean quicksort could be the answer, but here in their question actually I just saw that they have given the algorithm chooses the first element as a pivot. So they are saying that algorithm can't even choose this 39 as a pivot. Okay, they are saying the first element as a pivot. Algorithm chooses the first element as a pivot. They've completely given. So this is the question of test. Okay, question asked in test. Question asked in AIMT. Okay, this is a question asked in test. So they are saying that first element if we choose as a pivot, but you can also choose the last element as a pivot, right? You can also choose the last element also as a pivot. Now, if you choose, let's suppose, last element as a pivot, then maybe this rearrangement doesn't really matter. Okay, see, the rearrangement really depends on that what kind of algorithm you are writing. Okay, so if you're writing, maybe you can definitely rearrange them as far as quicksort idea is concerned. Okay, as far as quicksort quicksort idea is concerned, it does not really matter the arrangement of left and right element of the pivot. Okay, left and right elements of the pivot. What really matters is that pivot should be in the should be here it could be lesser than equal to pivot, here could be right greater than equal to pivot, but what is the arrangement of this doesn't really matter. What is the arrangement of this doesn't really matter. It depends on your own implementation. So that's why actually the answer okay, either the answer should be A and C, or I should actually in the question I will mention it later on that the first element should be the pivot. Okay, otherwise it is little, not very good question, I will say. So I will mention that what do they mean by quick sort. Okay, I will mention that. And it cannot be insertion sort. Reason being is that insertion sort have one invariant, is that like, I mean, you will say that, okay, you will first take this, and then you will fit it, right? You will fit it, and then you will take this, you will take this, you will fit it, and then you will take this, you will fit it, and so on. So basically you can check it, it won't be followed by insertion sort. So the answer is merge sort and quick sort. But in the quick sort, I will mention that if the first element is the pivot, then the answer is merge sort only. Okay. So answer is, I will say, merge sort only. If quick sort, I will mention quick sort first element as pivot. Okay. Now let's see this question. This question was easy one only. The similar question, how many of you know the similar question has been asked in GATE DA 2024? Similar question has been asked in GATE DA 2024. Yeah, there is no restriction that you want to choose pivot which one. It should be mentioned in the quick sort. It should be mentioned. So see here they are saying that these probabilities are given, right? So maybe you can say the probability of A and A complement are given to you, right? And then you can say this probability is 0.3. You can do quickly by the tree diagram. This is 0.7, and then from here this is B and B complement. From here this is also B and B complement. Now you will say that, okay, this probability is given to you 0.45, then it will be automatically 0.55, right? Because given A, the probability of B is given, right? So this is the probability which is given, and this is the probability which is there, right? Now what about this? This probability, is this given? A complement, given A complement, B probability is 0.25. So hence this probability is 0.75, right? So these probabilities are given to you. Now what you need to do? You need to calculate probability of A complement given B, which will be probability of A complement and B upon probability of B. Okay, A complement and B. So A complement and B is this one divided by probability of B, right? These, and I mean this one and this one. So basically if this is X, this is Y. So they're asking, or maybe let's suppose this is X, this is Y. So they're asking X upon X plus Y, right? You can solve this question. And what is the value of Y? 0.3 into 0.45. What is the value of X? X is nothing but 0.7 into 0.25. Yes, this question was easy one. Okay, if you make this tree, then you are very, very confident that you are going in the right direction, and it really makes the question calculation faster and easier. How many of you solve this question using tree? How many of you solve this question using tree? Let me know. How many of you solve this question using tree? So answer is coming out to be D, right? Okay. So let's see this question. I hope this question was easy enough. Answer is CD. Should I solve this question? So they are saying A is a matrix of 20 into 11, which means 20 rows and 11 columns. So these are the 11 columns. It is in R20, right? Okay, 20 rows and 11 columns. Okay, the rank of A is 12. So, okay, is this possible to have rank of A is 12? Obviously no, because the 11 columns are there. So how it is possible? The rank of A and B are not related. What is B here? B get a matrix B that has 12 non-zero rows. Okay, so after elementary row operations, we get B, which is having 12 non-zero rows. Okay, and all of the remaining 8 zero rows and 12 non-zero. They are saying are not related. No, rank of A and rank of B are actually equal, right? Actually equal. Rank of A and rank of B are actually equal. They are related. If V is a vector such that AB equal to 0, then VB is also 0. Yes, so basically that's how we solve system of equation, right? System of linear equations. solutions doesn't change. So tell me, if you are given with some A matrix, okay, if you are given, so let's suppose 1 2 3 2 3 5 1 9 7, something like this. Let's suppose this is the A matrix which is given to you, and someone says that find Ax equal to 0, all the solutions of Ax equal to 0. Then don't you apply the elementary row operations here? Row operations, and don't you get B first, and then don't you solve Bx equal to 0, and don't you say that A and B has the same solution? So basically whatever is the solution for Bx equal to 0 is same the solution for Ax equal to 0, right? You don't need to check it. You should know this, that elementary row operation doesn't change the solution space. That is called basically basically that's called, you can say, the null space, but that's not really required for gate CSE. But it doesn't change solution. Basically, you can say it doesn't change solutions. Okay. Is this understood to everyone that it doesn't change solutions? Okay, okay, great. So that's also true. That's true basically. Rank of B is at most 11. Okay, because this is having 11 columns, and yeah, at most 11. Yes, rank of A is also at most 11, right? Rank of A is also or at most 11. No, no, no. See, either it is Ax equal to 0 or Ax equal to B. Okay, so either it is Ax equal to 0 or Ax equal to B. It doesn't matter. You solve using the elementary row operations. Okay, elementary row operations only. And here the elementary row operations are on AB, right? Here the elementary or row operations generally, you can apply on A0, doesn't matter, or A, you can apply on A, right? Only on A. So basically here also the solutions doesn't change. Here also solutions doesn't change. Okay, solution doesn't change in any of this, neither in this nor in this. Okay, either it is X equal to 0, you solve using the elementary row operations only. Understood? Okay, so we solve using the elementary row operations only. Either this is X equal to 0 or X equal to B. So the solutions after the row operation doesn't really change. So yeah, that's true. Okay, yeah, this is a nice question. How many of you were able to solve that? How many of you were able to solve that? See, have you seen my video which I talked about this user stack, kernel stack, like these things? By the way, this question I have taken from IIT Bombay. Okay, directly from IIT Bombay. I have not changed even I have not changed anything here. Basically, directly from this. Okay, I have taken the question. So the question answer is A. And how many of you have seen this particular marathon which I have taken? Okay, which I have taken about the thread system call. If you have seen this marathon, then you must have solved this question, right? Here I've told you that you are in the kernel stack. You will first save the context in the kernel stack, then you will switch to the scheduler, and then you will restore the context from this kernel stack, and then you will go to the P2. So basically currently you are in P1. You go here, you go to its kernel stack, save the context, you go to the scheduler, you go to the P2 kernel stack, you restore the context, and then you go to P2, right? I have told all the steps very clearly. I have told all the steps. So here in this question, step A is basically saving the context of P1 and restoring the context of P2, which involves shifting the stack pointer, right? Stack pointer you will shift first, and then program counter. So first stack pointer and then program counter. So even occurs before E2. Hence A is the right answer here. Okay, A is the right answer here. Let me know if you have understood this. Okay, if you have seen this, then it is okay. Otherwise now don't get panic. Okay, that's okay if you have not seen this. I'm just telling you that this first need to restore the context here, save the context here, and then restore the context from this stack, and then we'll go to the P2 address space, right? By the way, this question I've directly taken from IIT Bombay. Understood? Okay. Now this was, I think, easy question. How many of you were able to solve this question? Okay, I'm skipping this question because this is easy question. C is the correct answer here. A runs for 100 millisecond, B runs for 100 millisecond, and then A runs for 400 millisecond, like that, right? Okay, B, this length is only 100 millisecond. So A will run for see, it is coming at t equal to 0, it is coming at t equal to 100 millisecond. So the shortest one will be at 100 millisecond, the shortest one will be B. So that's why A will run first 100, and then B will run 100, B will run 100, and this is A which will run 100, and then A will run 400, right? Okay. Okay. So what about this question? How many of you did? This question I have taken from NUS University. It is really a good question, a nice question. I mean, you should be able to solve it. Otherwise, that's okay. See, they are asking about the false, right? Asking about the false. To perform DNS lookup, a host first discover IP address of its local DNS using DSCP. So, is this true or false? This is true, right? DSCP provide. Let me just tell you, DSCP provide first thing, which is own IP address. I mean, my own IP address, basically my host own IP address, local DNS, and default gateway, right? Default gateway. This is all DSCP provide to you. So to perform DNS lookup, you host must first discover IP address of the DNS. Yes, using the DSCP. Yes, that's true. Using the DSCP should know that what is the local DNS, right? So that's true actually. That's true. To transmit a packet outside the host subnet, a host must first discover IP address of its first hop router using DSCP. No. If it wants to see, uh, if it wants to basically send the packet outside the network, then it should be knowing first of all what is the IP, right? If it doesn't know the IP, then it will be done using the DNS, not using the DSCP. So should be DNS here. It should be DNS here. That's why this is false, and that's why this is true. Okay, using the DNS, you get to know the IP address of someone else. Okay, that's why this is true. Using the DSCP, you doesn't get to know the IP address of someone else, some host. Okay, you get to know the IP address of local DNS. You get to know the IP address of the default gateway. You don't get to know IP address of, let's suppose this is R1, this is R2. Using the DSCP, you don't get to know the IP address of B, right? You don't get to know. Using the DNS, you get to know. This is a direct question, direct screenshot from NUS University. Okay, this is a direct screenshot from NUS University. So, what is the doubt that you have, Ayush? Using the DSCP, do you really get the IP address of B? Or using the DSCP, you will be getting IP address of R1, which is the default gateway, or local DNS, or your own IP address. So, DSCP provides these things, right? Okay, first hope. Okay, they are saying first hope. Okay, they are not saying the destination. Sorry about it. Destination is written here. Destination is written here. So this is true. This is true because destination is written here. But here it is written first hop. So what you need, you need the IP address of the first hop. Do you ever need it? Do you ever need the IP address of the first hop? Tell me. You need MAC address of the first hop, right? You need MAC address using the ARP. You need MAC address. Do you ever need the IP address of first hop? Tell me, how many of you need? You never need, right? You never need the IP address of the first hop. Basically, if A is sending to the first hop, which is R1, you don't need the IP address of this. I mean, okay. So, see, to transfer the packet outside the host subnet, host must first discover the IP address. No, it doesn't need the IP address, right? As long as you have the MAC address, then that's good. Okay, but yeah, that's a good question. But to have the MAC address itself, we need to know the IP address, right? Okay, let me just tell you the steps, and probably it will be more clear after that. This is R2 and then this is B, right? Let me just tell you the steps. So suppose A wants to send to B. Now what are the steps? Step 1, A needs to know own IP address, right? And also let's suppose A needs to know, basically I mean generally A needs to know own IP address, local host, sorry, local DNS, and also the default gateway, right? So basically, as a first step, it just needs to know its own IP address to communicate with the internet. Now let me just tell you the step two. Okay, step two. Now if A wants to send to B, then it must be knowing the IP address of B. So using DNS, now A needs to know IP of B using DNS. Okay, that will be done using DNS. But how it will get the DNS? DNS, local DNS? Local DNS will be done using DSCP. Okay. So basically, A needs to know the IP address of B. For that itself, it needs to know the DNS, local DNS server address. So that DSCP will provide. And what is the third step? It will get to know the IP address. It will check whether using the A IP and B IP, using A's IP and B's IP, A will determine if B is in same subnet or different, right? Now suppose A get to know that B is in the different subnet, then okay, so then step 4, default gateway if B is in different subnet, right? Now step 5 will be A needs to know the default gateway MAC address. A need to know MAC address, right? And then step 6. But to get to know the default gateway MAC address, see, default gateway MAC address it needs to know. But to get to know the default gateway MAC address, it must know default gateway IP address itself to get the ARP, right? Using ARP, basically, it will be done, but it must know default gateway IP address also. That will be using DSCP if it doesn't really have default gateway IP address, and that will be done using DSCP. Okay, and then once it knows the MAC address, then it will send to R1, right? Then send to R1 using MAC address, and also obviously in the destination IP address keep the B address, right? So basically, yeah, that's true. This should be true, right? So actually, at this link, I think the answer was not given, but they're saying about the false. Okay, it should be true, right? So in that case, there is nothing false. should be true. Okay, to send, let's just check this. To send a packet to another host in the same subnet, host A must first discover the MAC address of the destination using ARP. Another host in the same subnet. Yes, destination or MAC address. Yeah, that's also true. That's also true. Can do using ICMP also. No, ICMP is not used like this. Okay, we get to know the information about the gateway router using router solicitation ICMP. No, ICMP is the error control messages. I mean, just to tell whether there is something. Okay, ICMP are not used for these kind of things. ICMP messages are not used for these kind of things. So these are the steps. I hope the steps are clear. Actually, this question must be asking either true, or if it is asking for false, then all are actually true. Okay, cool. So here all are true, because using DSCP you should be first knowing the uh, the IP address of the R1 or the default gateway. Okay. So should I tell you the steps again? Let me just tell you the steps again. If this is R1, this is R2, this is B, right? Then A needs to know the IP address of its own using DSCP. First call is DSCP, right? DSCP, which is, you can say, mandatory. Okay. So first call is DSCP to know the IP address of my own. Then once I know the IP address of my own, now I want to send the packet to B. Now I have the IP address of, sorry, I know who is B, which means google.com. Let's suppose this is google.com. And now I need the DNS, right? I need the DNS. So that will be DNS. Now for the local DNS itself, I might be needing DSCP again, right? I mean, where is the DNS? So I might be needing DSCP again, depending on whether this DSCP have provided me the local DNS IP address which is expired or not. Okay, maybe it is having some time stamp or something. So maybe I can say it is optional. Okay, depending on that whether this DSCP is useful to get the DNS or not. Okay, so this is for, I can say, IP of A. This is for DNS, local DNS, and then what else you need? After that, once you have this, then you will be sending to the local DNS, and once you get the IP address, you will calculate whether it is in the same network or not. If it is in different network, you need to send to R1, right? You need to send to R1 first. You need to know the MAC address of R1. So for that, you again need to know the IP address of R1. Okay, so this is for IP address of R1. Okay, suppose the IP address of R1, if this help, then that's okay. Otherwise the IP address of R1, you can again make a DSCP call to get the IP address of R1, and then what you will do? You will send to R1 using ARP. You will get the MAC address of R1, right? You will get the MAC address of R1, and then you will send to R1, right? So these are the calls that you need. Okay, great, cool. Now let's see this question. In this question, the answer is A and C. Basically, this question is simple. They're just asking for synthesized attribute. Okay, so synthesized attribute is basically someone who is, if we are having this kind of production, then the synthesized attribute will be the attribute of A, which means the attribute which is being calculated using the children. So the synthesized attribute is this. This one is the synthesized attribute. And then if we talk about this B, then B.X is also the synthesized attribute. Here in this production C.X is a synthesized attribute. So if, okay, C.X is not even the option. So if they're asking for the synthesized attribute, you just check the production, and this production can define the synthesized attribute only for A, which means every other attribute, this is inherited. Okay, only for B the synthesis can be defined here. This must be inherited. Okay, similarly okay, so here this is the synthesized, right? Now this is inherited not because equal to a. Okay, some people have argued that because it is taking the value from left. No, it is a constant. This b dot b equal to a is just a constant. Okay, it doesn't really matter what is written in this constant, right? You are not taking the value from this left sibling or something. It doesn't really matter. You may write 1 also, you may write 2 also. It is inherited because in this particular production you can define synthesized attribute of a and inherited attributes of this. Okay, for every non-terminal. I hope that is fine. Now let's have the interesting question. Suppose these are the two productions. Now you tell me, is this synthesized or inherited? See, here the only a synthesized can be defined, so this must be inherited. And here b, only the b synthesized can be defined, so this must be synthesized. Okay, this must be synthesized. So A and C are the answers here. A and C are the answers here. Understood? No, here B dot B, which I'm saying here, it could see, synthesized attribute says that you are going to take the attribute from the children, right? From the children. Even if it is a constant, that's okay. You can say it's a constant function of the children, right? Something like that, right? You can say the constant function of the children. See, tell me, is this a function of x? Yeah, it is a constant function, you can say, right? You can, if you want, you can treat it as a constant function of x. So basically, this is a constant number, right? This is a constant number here. So here in this kind of production, you can only define the synthesized attribute of b, right? Okay. This is a constant. This b is a constant here, which is okay. Which aligns with the, for every non-terminal, that's okay, because this aligns with the definition, which is saying the function of this, that is fine, because it is a constant function. Okay. So I hope that was okay to everyone. What is statically allocated? So if it is statically allocated, then that's allocated in the absolute address of the program's data space, right? I mean, the address is fixed, that okay, this is the address, right? I mean, the logical address is fixed. So the address or the logical address, you can say, right? The address or the logical address is fixed. Okay, the logical address is fixed. Now, no, stack heap, that's wrong. And then not defined as a local variable. No, you can define. Okay, understood? Tell me, is the physical address fixed? No. If you are using, especially if you are using relocatable code that generally everyone uses, then the physical address is not fixed. You can relocate it anywhere. Okay. So what about this? What about this question? Absolute address means virtual address? No, it depends on that what actually you are saying. If it is relocatable, then yes, absolute address is virtual address. If it is relocatable, if it is not relocatable, then absolute address is also the physical address, because that's what you are saying, that okay, it is not relocatable, this is fixed, right? Absolute means that you have given it a fix. If it is not relocatable, which means generally it's not the case, but suppose you are talking about very old system which is not relocatable, then the absolute address is same as the physical address. Okay. So I hope that's okay. The answer, this easy question, the answer is B. Okay. Okay. Tell me, can I skip this, or there was some problem here? The answer is given here. The answer is B. Okay. The explanation is also here. If you want, you can read it out. Let me know if you want me to skip or not. So what they are saying, suppose you implement a queue using the singly linked list and the head and tail pointers, so that front of the queue is a tail of the list. So basically they are saying that you are using singly linked list. So front of the queue is the tail of the list. So this is the front. Front is the place where the DQ will happen. Okay. So here you want to DQ basically. Here you want to DQ. And this is the tail of the queue. Here you want to actually NQ. You can say you want to NQ here. Okay. Or rear or whatever. Okay. The rear of the queue is the head of the list. Okay. Head of the list is the rear. Rear means basically they are saying NQ will happen here. Okay. So basically you want to NQ here. I mean, if you want to NQ, you will be appending here, and you want to DQ here. Okay. So order of 1 for NQ. If what is the worst possible time for NQ and DQ? With head and tail pointers, so that, okay, so one pointer is pointing here. So the head pointer. Okay. So these are the two pointers basically you have, right? Okay. Two pointers you have. Now, if you want to DQ, okay, or maybe the tail pointer, whatever the name, if you want to DQ, is this possible to DQ just pointing this? So I think it is not possible. So DQ will be taking order of n time. Okay. DQ will be taking order of n time. So that's the thing, right? Okay. Now let me know if this question is understood to everyone. Is this question understood? So what they're asking in this question is that what are the physical letters that are basically accessible? So you can say that you are accessing logical letters that you are accessing is 10 and then 70, right? 10 and 70. These are the two addresses you are accessing, 10 and 70. You can convert 10. If you convert 10, you will see that, okay, this is the virtual page number 0. Why? Because the page size is 32 bytes, right? The page size is 32 bytes. Okay. So since the page size is 32 bytes, so that is why 10 will be in the page 0. 10 will be the page 0, right? Because you can just take a mod. So 10 will be the page 0, which means the physical page number 1. Okay. So basically you can say for logical address 10, physical address will be, you can say the offset will be 10 itself, right? And the physical frame number is 1, and the offset is 10 itself, right? Offset is 10 itself. So basically, if the physical frame number is 1 and this is 32 bytes, so 32 you need to multiply, and then I'm doing it a little quickly, but I hope that's fine. 32 plus 10, it will be 42. Okay, so 42 will be accessed, and if this is 70, then 70 mod 32, what it will be? 2, right? I mean, you will say that 2 will be, if you divide it, then 2 will be the answer. If you divide it, then it will be divisible by, it is not completely divisible, so 2 is here, and then this is 64 and 6. Okay, so 6 is offset, right? So offset is 6. Physical frame number, sorry, this is virtual frame number is 2. Now, if virtual frame number is 2, then physical frame number is 3, right? So offset will remain same. And then physical frame number is 3, right? Now from here, it means what? Frame number 0, frame number 1, frame number 2. These are the 3 frames above me. So which means if you want to know my address, then 3 frames above me, and then within me, this is 6 more bytes, right? So it will be 696 plus 6, which is 102, right? Which is 102, right? Yes, B and C are the answers here. Okay, B and C are the answers. So they are saying fetch and execute. If you fetch it, then 10 is going to get access. At the fetch time, 10 is going to get access. At the execute time, 70 is going to get access, right? Which is the logical numbers. Okay, so this is a really nice line, that fetch and execute. If you fetch it, then 10. If you execute it, then 70. If they only say only at the fetch time, not at the execute time, then only 10, right? Then only 10. Something like this. Okay. Now let's see this. This question is easy question, I think. How many of you were able to solve? Okay. So in this question, they are saying that if we have two functions, then do you think that they will run forever? No. It may be possible that one of the wake up call or one of the block call may get wasted. Let me just tell you how. Earlier, if you want to access this, it will get blocked, right? It will get blocked. Then B will get printed, and then it will wake up this A, right? So this will wake up, and then A will get printed probably. Now, what may so happen that it can wake up this B, and if B is not even blocked, this wake up call may get wasted, right? This may get wasted, right? May get wasted. May get wasted. This may get wasted. This is important here. Okay. Since this may get wasted, that is the reason that both may be in the deadlock, right? And then how? Because if this is wasted, print A, and then there is no wake up. Let's suppose it is not even blocked yet, right? Not even blocked yet. So there is no wake up, then it will get blocked, and now it will also get blocked. So both will get blocked. So that's why it's a deadlock, right? Okay. And it will always run forever? No, will not always run forever, right? It may be possible to have the deadlock. So hence A is the answer. Okay. Now let's just see this question. In this question, they have given that let me not read out it completely. Let me just directly go to the question. They are saying A1, A2, A3, A3, A5, A6. This is the AC case that we are getting. A1, A2, A3, A3, A5, A6. Then what are the possibilities? See, in the question they are saying that this AX means that this is a cumulative acknowledgement, and AX means that A5 A5 means that all the packets till 5 has been came, right? So A1 means that all the packets till the packet number 1 has already come. So basically, if you are getting A1, which means the packet number 1 is delivered, you can say 1 is delivered. If you're getting A2, packet number 2 is delivered successfully. I mean, till 2 has been, everything has been delivered. If you're getting A3, then till 3 everything has been delivered. Now, if you're again getting A3, it must mean that some packet is delayed or something is like that, because they are sending ACK for every packet. If you are again getting A3, it must mean that maybe they have got A5, A6 or something. I mean, maybe multiple packets are delayed or something. Okay, there's some problem, but something has been reached, because then only you're getting some ACK. So something has been reached. Okay, so some has been reached. You don't know what. You don't at this moment. You don't know what has been reached. But 4 is definitely not yet reached. Probably, right? 4 is not yet reached. But yeah, okay, something has been reached. Maybe this A3 means maybe 5 is reached, maybe 6 is reached. Okay, but not 4. Okay, maybe 4 will get delivered later on, or you don't know, right? And then you're getting A5. Then what does this mean? Everything till 5 has been reached. Then what does this mean? See, this is not A4, and this is what you are saying. If this is not A4 and this is what you are saying, this is till A5 everything has been reached. So this must be 4 packet what? 4 packet 5, isn't it? And till this moment everything has been reached, then this is 4 packet 4. Okay, which means I mean, it might be the case that 4 has been little delayed, and then 5 has reached earlier. If 5 has reached earlier, I will say, see, if that's the case, I will send 1, maybe 2, maybe 3, then I will send 4 and I will send 5, right? And I will send later on 6. Okay. Now here 1 is reached, you will say okay, 1 is reached. 2 is reached, you will say okay, 2 is reached, right? A2. 3 is reached, you will say A3. 4 is, let's suppose, delayed, then you will be sending the ACK for 4 little late, and let's suppose 5 is reached, you will say A3 again, right? And now you will say A5, and then if 6 is reached, you will say A6. Right? Are you duplicating? Is network duplicating any ACK? See, the number of packets that we are sending is 6, and number of ACK we are getting is 6. Okay, 6 is the packet sent, and 6 is the ACK got, right? Packet sent, and 6 is ACK got. So there is no duplication. Okay, there is no duplication that we are getting. So data packet 4 is dropped. No, there is nothing less, nothing more. Okay, is it dropped? No, nothing less. Okay, these are the six ACKs that I'm getting, and after sending 6 packets, right? So for 6 packets, I will be getting 6 ACKs. So nothing less, nothing more. So data packet 4 has been dropped. If it has been dropped, how I will be getting A5? If it has been dropped, how I will be getting A5? 4 is delayed and arrived immediately after 5. Yes, that's true. Duplicated? No. If A3 is duplicated, then let's suppose this is duplicated, right? Let's suppose duplicated. Then where is the acknowledgement for 4? Where is the acknowledgement for 4? If this is duplicated, that's okay. Then where is A4? I agree that it might be duplicated, but it must be having A4 also, right? Where is A4 then? Okay. A3 was duplicated. The packet is duplicated. No, neither the ACK nor the packet, right? Okay. So this question is having B as an answer. This question is from Berkeley University, right? Now let's just see this question. Is this question okay to everyone? Or there was some doubt in this question? Let me know. There was some doubt, or is this was this okay? No, network can duplicate. Network can duplicate the packets. Network can duplicate, but here packet either ACK it can duplicate or the data it can duplicate. But here it was not the case. Okay, so let me just skip this question. You can try this question, right? Similarly, I'm skipping this question. Okay, so in this question they are saying that you are having n into n plus 1 by 2 comparisons, which means every of the key is basically every of the key. I mean, if you want to verify, then everything has to be basically getting compare with everyone, which means it must be the skewed tree, right? Skewed maybe like this, anything, but it must be a skewed tree. Which means if you want to verify for this root 1 comparison, if you want to verify for this 2 comparison, if you want to verify for this 3 comparisons, right? Like this. I mean, order might not be the same. You may verify first for this, which means first 4 comparison, then maybe this can come, maybe 2 comparisons, and like this, right? So basically this is the skewed tree. So there will be only one leaf. Okay. Okay, similarly, this was also easy question. I'm skipping this. This was also easy question, right? Okay, let me know if that is okay. This was a nice question, by the way. So this AIMT was a nice one. It's not, it was very, very easy or something. I think it was a nice AIMT. Yeah, let's just solve this question. What they're saying, that PN makes multiple calls to the procedure QM. Okay, so see, this question I think little nice, right? 46, and then this was easy one. This is also easy to understand. Okay, so let's just solve this question. I think this is one of the nice question. Okay, so what they're saying, there is a function called PN, right? There is a function called PN. So PN is making a call to QM. Maybe m equal to n, maybe m equal to 2 power n, maybe m equal to log n or something, right? But yeah, it is not even given. Okay, they are saying that Pn is making a call to QM and runs in polynomial time. This is interesting. This is given to us, given that if you are making a call to QM, then it is given that you are running in polynomial time. This function is running in polynomial time. Tell me, if you are making a call, okay, to some function, maybe Q, and it is given that p has to be run in polynomial time, can you make a call exponential time? Okay, it is not given that you are calling q how many times, but tell me, are you calling q exponentially? See, let's suppose you are calling k times, and the time complexity of q is, let's suppose, t, okay, tm or something, okay, whatever it is, right? So basically if let's suppose you are calling it exponentially, is this possible if ultimately it has to be run in polynomial? No, right? This is not possible. So hence I can say whatever number of times I'm basically I'm executing this queue must be polynomial only, or maybe lesser, but it cannot be more than polynomial. So maybe I'm calling this queue k times. Okay, let's suppose for I equal to 1 to k, maybe I'm calling it k times, right? And then the time complexity of q, maybe it is the time complexity of q. Okay, you can say, let's just say it is qm. Okay, the time complexity of q, I'm just writing qm. Okay, so here, if the ultimately this number is polynomial, maybe n cube or something, tell me, can this number is exponential? No, right? If this has to be greater than or equal to 1, basically 1 2 3 something like this. Okay, so basically if ultimately this is n or n cube or n power 4 or polynomial, then obviously this qm cannot be exponential, first of all, right? Anyway, I'm just telling you one observation here. Now they're saying this qm has been replaced by rm. So due to some reason, okay, maybe there is some reason because of which this qm has been replaced. This qm has been replaced by rm. Now you tell me the new time complexity. This is new time complexity, isn't it? Will this k change? Will this k change if you are only basically changing? Okay, let's suppose you are only changing this from this q. You are only changing to r. Tell me, will this k change? This is the new time complexity, and this is the old time complexity, right? Old and this is new. And the old is given to us, that n cube. New is not given, that's fine. New is not given, but old is given to us, that is n cube. So tell me from old, can you not infer the value of k? What is the value of k from old? From old, you can say it is n power k. I mean n power 3, n power 4, something like this. So it must be polynomial only. It cannot be exponential or something, right? So from here you can say these two, I mean either of this cannot be exponential. Okay, anyway, I have replaced this q with r, so that's okay. But this k, you can say it cannot be exponential. So basically this k must be polynomial or maybe lesser than polynomial, that's fine, but it cannot be exponential basically. Okay, so let me write it that what is given to us is something like this. See, what is given to us is something like this. They are saying old you are having k into qm, new you are having k into rm, right? New you are having k into rm. This whole thing is polynomial. Let me just take it n. Okay, I mean n cube or anything. This whole thing is polynomial. It is also given. Okay. Now Pn still runs in n. Tell me, is this necessary that it will always run in n? Won't it depends on Rm? Maybe Rm value of m could be anything. Maybe Rm is taking too much of time, right? Maybe Rm is taking n cube or maybe 2 power n. So you don't know. This is new. You're sure about this k. You're sure about this k. This is polynomial, but not about this Rm, right? Will it run in polynomial time? Requires exponential time? No, you don't know whether it requires exponential. It runs in polynomial. You don't know. You don't know the new p. Okay, you don't know the new p. Pn runs in polynomial time in n if the number of calls made to q is proportional to log n. So they are saying k, if k is log n, then can you say it is polynomial? No, it will depend on r. Okay, if r is exponential, then how it can be polynomial? It will depend on the r. So they are saying is k is log n, then it need not be, right? Pn runs in polynomial time. Pn runs in polynomial time. If for each call qm, if for each call this qm, m is less than or equal to log n. So they are saying that it will run in polynomial time if for each call qm. So they are saying that okay, it had to be replaced by rm, which runs an exponential. Okay, so this rm, the exponential time, this time is given to us. Okay, this is given to us is 2 power m. Okay, sorry, this is given to us is 2 power m. So let me just read out the options again. It still runs in n, it still runs in exponential. So basically the value of m, I mean, it will depend. If m is n, then it is truly exponential in n also. If m is not n, then it is not exponential in n, right? So so it will depend on the value of m. If m is log n, then it is also polynomial, right? It is also polynomial. So it is polynomial, it is also polynomial. So in that case, because this m is log n, right? In that case, D is the answer. See, should I solve this again? I hope that is okay. That this is old one, this is new one. You need to check whether this new one is polynomial or not. And this is given that it is exponential in m. Okay, this is exponential in m. If the m value is less than or equal to log n, then this is a linear in n. Okay, this is linear in n if m equal to log n. Okay, so which is what option D is saying. How P replace? It's just like wherever Q is written, they are saying each call is replaced. Okay, each call is replaced. Each call of to QM will be get replaced by RM. Each call is getting replaced. Right? Okay, let me explain this again. So they are saying that you are basically replacing earlier old, you are having K into QM. Now new you are having K into RM. I hope that's okay. Let me know how many of you is okay with this. How many of you is okay with this? How many of you are okay with this? I hope that's fine because you are just replacing QM with RM, right? Now it is also given that this is nothing but new is given to you K into 2 power m. This is nothing but K into 2 power m. Now K is given to you is basically linear because it has to be polynomial, right? It cannot be exponential or something because otherwise the whole time complexity is given here. Using the whole time complexity, which is polynomial, you can say K must be polynomial itself. So it is polynomial. If this is also polynomial in n, then you can do it. Otherwise, you won't be able to do it, right? Right? You won't be able to do it. Now, let's just check. P is still run in n. You don't know. It depends on the value of C. It is basically the new time complexity is, you can say K is, let's suppose n cube. Okay, this is K. Let's suppose into 2 power m. This is the new time complexity. This is the new time complexity. Now it will depend value of m on the value of m. Okay, still run in polynomial, you don't know. In exponential, you don't know, right? I mean, if m is log n, then it is still polynomial. If m is n, then it is exponential. Pn run in polynomial time if number of calls made to q is proportional to log n. So they are saying if this k has been log n, no, it doesn't only depend on k. Okay, k upper bound I know it cannot be exponential, but this can be exponential, right? It has to depend on this also. So now if m is log n, then yes, then ultimately the whole thing is n cube into n, which is polynomial only. Yeah, you can think in that way. You can think the polynomial, the exponential as what you are saying, n power n. Yeah, m power m also you can think. If it is less than or equal to log n, okay, so it will be little complicated, but yeah, log n power log n cube. Just compare between log n power log n. It is little, I think, complicated. N power 3. Which one is greater, by the way? If you, let's suppose n power 4, n power 5. If you compare, Is it greater than polynomial? Let's just check. If you take the log, it will be log n into log n. It is log n. Yeah, this is greater. Okay, this is strictly greater basically. In just a second. So exponential in n, what does this really mean? Okay, actually, generally the exponential means 2 power n only. I mean the constant power n. So exponential is exponential in n is 2 power n or n power n. Let me just Google this. I mean, which one I should be preferring. So in the question, it is written runs an exponential time in m. So by the way, generally this exponential means this only, and I have taken this question from CMI University. So basically, this question is from CMI University, CMI 2020. If you just Google out this question, you will get the link also, I think, right? So here is the answer from the Stack Exchange also. So they have given the answer, and they have also assumed that if Rn runs in exponentially m, this means that running Rm is informally something like 2 power n. More formally, they have also assumed this is 2 power m. Okay, so exponentially, I think they treat it as 2 power m. I mean the constant power m also only if they say exponential. Okay, if they say exponential, then they mean the constant power m only. So what does this n power n call? N power n, I think they must be having different name for this. It might not be exponential in n. I mean, you are right that should be treated. What does this phrase exponential in n means? Let me just Google this. So there is a question on Stack Overflow itself, and the question itself says that what does this phrase exponential in n means? Okay, so what does this phrase exponential in n means? And then if you see that they are saying one of the comment, there is no answer of this question, but one of the comment is saying exponential in n means exponential when consider as function of n. For example, c is exponential on n but not linear. So they have also given the constant power n as an example. Okay, so generally it means actually, but yeah, this might be debatable even. Okay, it seems like it is debatable point. It's a very good point that you have raised. Okay, so it seems like it is a debatable point that exponential in n. Generally, I have also seen e power n, but you are also right. This is also what we can say n power n, right? N power n is also exponential in n. Okay, but it's too much, right? I mean, too much exponential. Okay. So if these kind of things comes in gate, then we can definitely debate on this, right? If there is no standard definition that whether n power n can be considered as a as an exponential or not, then it is debatable. Okay. So now let's just move to the next thing. Okay, now let's just move to the next thing, which is this. So I think this was okay to everyone. So they are saying based on the second coordinate we are doing, right? Based on the second coordinate. So you can do the stable sort, and whenever the second coordinate is same, between these two this is same, and between these two, right? Between these two this is same. So 357 must be coming before, then 659, and 718 should be coming before, right? 718 and then 614. So basically 718 and 614. So what is the answer? C is the answer, because 718 is coming before 614 and 357 should be coming before 659. Okay, you need to maintain this order. Okay, you need to maintain this order, right? Okay, great. Was this easy one? See here what you needed to do. If you solve this, then it will come out to be, I think if you solve this, then this is minus b plus minus b square minus 4ac, right? So minus 1 by 2 plus minus 1 by 4 minus 4 h1 c, right? So basically this must be greater than or equal to 0, right? So you know that, how many of you were able to solve, by the way? So c must be greater than or equal to 1 by 16 or less than or equal to. This will be less than or equal to, right? Less than or equal to 1 by 16. Okay. So here you will say that, okay, this is chosen uniformly from 0 to 1. So if it is a uniform, okay, if it is a uniform distribution from 0 to 1 and less than or equal to 1 by 16, this is 1 by 16, right? So you need to take this area, right? And what is this constant? Can you tell me? Do everyone remember? See, in the uniform case, you can use using the geometry, right? So what, by the way, what is this constant? Length into width should be 1. So if this is 1, then this has to be 1, right? This has to be 1. Now if you need to find out this area, then this is 1 by 16. So the probability that C is less than or equal to 1 by 16 is basically 1 by 16 only. Right? It was also a good question. Easy one, but good. It is combining one or two concepts, but it was really a nice question. I really like this question. Although it was easy question, but I really like this question. Okay. Were you able to solve this question? This was similar to the question which has been asked in GATE DA. I put it similar to the question which has been asked in GATE DA 2024. How many of you were able to solve this question? So what they are saying is that not possible. Okay, not possible. See, the answer, let me just tell you, the answers are A, B and D, which means only C was possible. Okay, this was possible. Should I solve this question, or you were able to solve this? Let me know. So this question is not a very hard question. This is easy question only. Let me just solve this question. So some people are asking that why this A is not the answer. See, M is a matrix of 2 cross 2, right? This is a 2 cross 2 matrix. And then in this 2 cross 2 matrix, what they are saying is that no solution for some P, but and exactly one solution for other P. See, if there is exactly one solution, then what you can say? Exactly one solution is possible only when these are linearly independent. See, if you are having exactly one solution, this must be linearly independent, right? If this is linearly independent, then this must be, since this is two vectors in R2, which are linearly independent, two vectors in R2 are linearly independent, must mean that they must fill the space, right? They fill the space. Okay, if anyone has seen our linear algebra lectures, then I'm telling in that perspective. Okay, so these are the two vectors in R2. It means that they fill the space because these are linearly independent. It means there is no solution. This is not possible. Okay, this is not possible, no solution. Okay, this is not possible to have no solution, which means it is false basically, right? It is not possible. Exactly one solution for some P, which means these are linearly independent. Again, exactly one solution means linearly independent, but not all P. Okay, okay, these are linearly independent, by the way, and more than one solution. So they are saying more than one solution for other P. If these are linearly independent, then how can be there will be more than one solution, right? See, linearly independent means exactly one solution. See here, if we are having two vectors in R2 and they are producing just one vector in R2 here, and now you are saying exactly one solution, it means what? It means you're filling the space. These are linearly independent, filling the space, and everything is fine, right? Everything is fine, filling the space. So if you're filling the space, there is no solution. That's not even possible to have no solution or more than one solution. So basically, if linearly independent or exactly one solution, then always exactly one solution for every vector. No solution, not possible. More than one solution, not possible. Okay. If there is exactly one solution is there, then no solution or more than one solution not possible. Always exactly one solution for 2 cross 2. Understood? No solution for some p, more than one solution for other p. So is this possible? So they are saying no solution for some p, which means if there is no solution for some p, then not filling the space, which means linearly dependent, right? Linearly dependent, and more than one solution. Yeah, that's possible. That's possible, right? That's possible. I mean, it means linearly dependent, no solution for all p, and one solution for. Then you can have one solution and more than one solution for other p. Yeah, that's possible, right? No solution for some p. Okay, there is no solution for some p. It means they're linearly dependent. And exactly one solution? No, that's not possible. Exactly one solution for p and more than one solution? No. Exactly. So at this point, this is not possible. Okay, this line is not possible. If there is no solution, it means they are linearly dependent because it is 2 cross 2 or 3 cross 3, whatever. I mean, it is a square matrix. If there is a no solution for some p, it actually means the linearly dependent. Then exactly one solution is not possible in case of linearly dependent, right? Okay. I hope this was also easy question. You just plug in the value of 0 0. I mean 0 here, 0 0 here. You will check that okay, this is true. Okay, 0 1 0 0. This is also true. So that's why I think ABC was the answer here, right? You just needed to plug in the values. Okay. So for this question, this was a nice question, I think. For this question, you just need to understand that how shift reduce parsers are actually working, right? How shift reduce parsers are actually working. See, this is they are saying this is the reduction number one. Then once you reduce this x to p, okay, once you reduce this x to p, tell me is in the stack if you are going from this to s to p, this state, then will you be shifting something, or if there is a reduction possible that is given here, right, then you will be reducing, right? So basically this is again the reduction from p to t, right? Again the reduction, then this is again the reduction, and now since there is no reduction, that's why you will shifting it, then reduction, right? So basically you will say this 2, it is number 3, it is number 4, it is number 5, and then there is in the stack, after the 5 in the stack, you will be having e plus t, right? E plus t, and then star and z is here, right? Star and z is here, e plus t is there, star and z is here. Now you Okay, so now from this e plus t, you are saying that okay, let's just, I mean, the past tree is given to us. Now basically you are saying that okay, it will be reduced later on. So the star will get shifted, and then this pz, this will be sixth number, and then this will be seventh number, and this will be eighth number. This was really a nice question. Okay, so you need to approach this intuitively, right? You need to approach this intuitively. You don't need to make the state diagram and these things. See, this is the very first it is given, this is the last it is given, right? Now obviously this will be the second one because this is the reduction what is given, right? If you are not doing it now, then when you will do it? After shifting. After shifting you can't do it because whatever is the handle, you need to treat it on the at that moment only, right? So if you have seen the lectures which I have already posted, but anyway, if you have not seen it, whatever way is possible in the exam, you do it, right? Whatever way is possible in the exam, you do it that way. So here, this is the second number, this is the third number, this is the fourth number, this is the fifth number, right? Because that's how the past tree is given. And then you are having e plus t. After the fifth number, you are having e plus t. Start z is yet to see, right? Start z is yet to see. E plus t is already there. But this e plus t, you can't reduce it to e because it is given that you are not reducing this e plus t, right? So basically, you're shifting now. I mean, you will reduce it later. So you need to shift it. So which means shift it, and then this is the next reduction, sixth number. This is the next reduction, which is seventh number, and this is the next reduction, which is eighth number. Okay. Is this understood now? Let me know. Okay, okay, great. No, this was really wonderful question. Let me just tell you that how to solve this. They are saying that which LLK is it is, right? See, in the predictive parser, what do? You have the predicted table, right? Which means, let's suppose this is the table, S and A and these things, right? Now you have this S in your hand, and these are the lookouts, right? These are the lookouts. So you will say that, okay, let's suppose this is LL1. If you want to make the table for LL1, you will put this here, right? You will say if the lookout is a small a, then I will go with this production. If the lookout is a small b, I will go with this production, isn't it? If this is the LL1, this could have been very easy, right? If this is the LL1, this could have been very easy. Okay. Now let's just see that if it is not LL1, then which LL it is. See, if S is in your hand, then tell me, do you really need multiple symbols, or if the next symbol is A, if this is the next symbol, if this is the next symbol, then you tell me which one will be using, this one will be using, or you will be using this one. Obviously, anyone can say that this will be used, right? If the next symbol is small b, if the next symbol is small b, then which one will be used? Then BAB will be used, right? So as far as S is concerned, only one symbol is enough to tell whether it is used or it is used, isn't it? So see, as far as S is concerned, only one symbol is enough. But let's see, what about A? What about A? Tell me, if next symbol is small a, can you decide whether it is what you want? I mean, if next symbol is small a, if next symbol is anyway small b, then it is error, right? You can't produce using a. But if next symbol is small a, can you decide whether this is what you want or this is what you want? No, right? No, right? No. So you can't decide using small a. What about you have access to two symbols? What about you also get to know that whether the next symbol is A or AB? Let's suppose you get to know that the next symbol is AA. If you get to know next symbol is A, will you ever go for this? Tell me, will you ever go for this? So using only one next symbol or one look ahead symbol, we can't decide, right? Using only one next symbol, we can't decide. Okay. Now the second point here is that if the next symbol is given to be, let's suppose if the next symbol is given to be small a or small a small b, if it is given to be small a, then will you ever go for this? No, right? So using if the small a, then it is fixed, then we will go for a gives b, a gives a, right? A gives a. What if the next symbol is ab? If next true symbol is ab, then can you decide whether you should be going for this or this? Let's just check. If the next symbol is AB, then maybe this or maybe this also, because once this is there, then you are having, then see, once this is there, once you replace this A, then maybe it is the case, right? See, you don't know the history. If the history also you know, in the LL we don't take the stack. Do LL has a stack? No. The LR parsing has the stack. LR parsing make use the stack. See, you very well you know that LL1 and LR1, which one is more powerful? LR1 is more powerful. See, both are using only one symbol. Still LR1 is more powerful. Why? Because uses one symbol plus a stack, and it uses only one symbol. That's the difference. Only one symbol uses one symbol. So it doesn't, LL things doesn't use stack, right? So basically, I don't know the history. Now, what I'm saying here is that if next is AB, then maybe you don't know. See. Let's suppose that the uh, string is, let's suppose, A. Okay. So these are the strings possible, right? Let's suppose this is the string that I'm looking for. Okay, I mean, first I will go for small a, capital A, small a, and from this capital A I want to make a call. Right, from this capital A I want to make a call. So I will check next two symbols. Right, I will check next two symbols. Now if you check next two symbols, then if this is AB, then you should be going for this or you should be going for this. That is my question. Okay, if this is AB, then definitely, okay, you tell me, can you make a definite call whether this or this? If this is AB, maybe this, maybe directly this, right? Or maybe this, and then ultimately, see, if I put A here, then maybe this, and then ultimately it could have been, see, let's suppose these are the two cases, right? I mean, I may be in this state, B, A, B. Now you are at this A, here also. At this A, you need to make a call using these two, okay? Using these two. So this is basically, you can say this is the number one, this is number one parse tree, this is number two string, this is number two parse tree. Now if you are here, right? Then you will check, okay, AB. Will you be sure that you will go for this or this? So here, which one you should be going? In case 2, you should be going for directly, okay, capital A. Okay, in both cases, actually, you need to go for this. But suppose this is just BAB. Okay, this is just BAB. See, what I'm trying to say here is that, suppose this is BAB is the string. Okay. Now, if BAB want to parse, okay, let's just parse BAB. You will go to this B, A, B. Now, on this A, can you take a call? Tell me whether you want to go to AB, because just looking two symbols, whether AB is required or maybe A is required. Can you take a call? No. Because just using two symbols you can't take a call, because the reason is that if you say that, okay, AB is required, then later you will find that, okay, AB was not even required, because here you need to look at the three symbols, right? You need to look at, okay, if AB dollar is there, then I will go for this, right? A. If AB dollar is there, then I will go for this. If let's suppose some other string, okay, maybe let's suppose B, and in between AB is there. If ABB is there, okay, S, B, A, and B. If ABB is there, then I will go for this AB, right? AB. So basically, next three symbols are required, whether it is AB dollar or ABB, right? To make a call, basically you can say just like this. From here only you can say, whenever S is in the hand, there is only one symbol required. Whenever A is in the hand, then is this two symbol enough? Let's just check. Okay, only one symbol is not enough. Definitely, is two symbol enough? If two symbol A is there, okay, A is there, then it is enough. Okay, I mean, that's okay. Then you will go for this. But if next two symbols are AB, can you take definitely a call whether to go for this or to go for this? That's the question. Okay, so here you can't take a call. You need to check whether it is AB. After that, what is this? If it is ABA, it may be ABA. It may be ABB, it may be AB dollar, okay? If it is ABA, actually you are talking about this, then you are basically going for A gives AB. Even if it is ABB, you are going for this. If it is dollar, then you will go for this, right? So next three symbols are required actually. If you are A in the current state, basically if you are dealing with the A, then if the next two symbols are small a, then you can definitely decide that you need to actually go for this only. You can't produce a small a using this, right? But the next two symbol is small b. Can you produce a small b using this? Yes, because at least small a I can produce, and then using this b may be produced by someone else, right? So at least small a I can produce. So yes, maybe this. So now you are again confused. So that's why maybe three symbols are required here. That, okay, if ABA is there, AB, after AB, what is this, right? ABA, ABB, or maybe after AB dollar is there. If ABA is there, then you are sure that basically you're talking about this, right? then you will say that, okay, you need AB. Here also you need AB. Maybe you're talking about this. If AB dollar is there, if just after that, if it is dollar, then actually you're talking about this. Then this is basically A only. Okay. So basically 3 symbols are required. So that's why it is LL3. Okay. That's why it is LL3. It was little unconventional, but a nice question. Okay. Little unconventional, but a nice question. Okay. This question I have taken from Toronto University. So I'm skipping this. I hope you were able to solve this. And for this particular question, I already made a video. Okay, in this video, I have completely solved this question nicely. Just see. Okay, just see this video if you are having any doubt here. Okay. Okay, for this particular question, I think the detailed explanation is already there on the Stack Overflow. Oh, sorry, on the Gate Overflow. So you can check. This question is the question number 61, and the detailed explanation is already put by one of the student, right? So let me just put the screenshot here. This is easy question if you have covered the floating point nicely. If you have covered floating point nicely, then this is easy question only. So just a second. Okay. So that's all. Okay. So that's all for AIMT discussion. I don't want to make it long because exam is very near. I don't want to make it long. Just keep it short. I wanted to keep it short and give you the idea of few questions which you were having doubt. So thank you everyone and best of luck for your exam. Okay, for GATE 2024. So best of luck for GATE 2024 and thank you everyone. Okay, great. Just let us know. Just comment out if you have any doubt. Comment out if you have liked any solution. Just comment and let us know. Inherited attribute question I have already taken. Okay, I have already taken that inherited attribute question. Okay.